This week, we're going to start looking at matrix algebra, and we're going to start with reviewing some notation just to make sure we're all on the same page. So first, to start, what is a matrix? A matrix is just two-dimensional array, essentially. It's n by p in the book notation, or David's lab slides used r by c. And it's really just a numerical table. This is how you can write sort of a generic matrix where you don't actually specify the individual elements, you just treat them as variables. Each element of a matrix has two indexes, and we traditionally use I for the row index and j for the column index. So for example, the element in the second row in the first column, it would be denoted x21. The element in the third row in the fifth column would be x35, and the element in the ith row and the jth column would be xij. So there are a bunch of special matrices, and let's review some of the ones that you've learned. So there's a square matrix, and a square matrix has the same number of rows and columns. There's a symmetric matrix, which is a square matrix that is also symmetrical above and below the diagonal. So you can write this as xij equals xji. A vector, which is a special column that only has one, or special matrix that either has one column or one row. A vector usually refers to a column vector, and a row vector would be called specifically a row vector. And this is how most software treats it. If you just call something a vector, it's usually treated as a column. You have to specify that it's a row vector if you want it to be treated as a row. And then there's a scalar, which is just a single value. So let's practice a little bit. This is a correlation matrix, which I'm sure everyone here is familiar with. And so what type of special matrix is a correlation matrix? So by definition, a correlation matrix is symmetrical, meaning it's also square, and it's symmetrical because every element below the diagonal matches the element above the diagonal. What about these three? So this first one is a row vector, the second one is a column vector, and the last one is a scalar. And how about this? This isn't a special matrix, at least I don't think it is. This is just a sort of generic 5 by 2 matrix. A matrix is usually referenced with bold uppercase lettering. A vector is usually referenced with bold lowercase lettering, and a scalar with just regular lowercase lettering, no bold. Of course, when you're writing by hand, you can't always bold your notation. So a couple common options you'll see are the double underline, with either the capital or lowercase letter for matrix or vector. Sometimes you'll also see if something is a vector, you'll write a lowercase letter with an arrow above it, and otherwise you'll use a capital letter. So let's take a look at this correlation matrix before. Let's name it X, and let's just make sure that we're all on the same page here a little bit more. First, what's x13? So to find x13, we go to the first row on the third column, and we get 0.41. How about x31? Well, we already know this is a symmetric matrix, so we know it's 0.41, but we can also go to the third row and the first column, and we see 0.41 is there as well. And then 0.23, or x23, we go to the second row and the third column, we see that's 0.36. And then x11 and x33 are both going to be 1, because any, in a correlation matrix, any element that has the same row and column index is always going to be 1. That's the diagonal. And there are your answers. And then how about here? This is our non-special matrix. This is just a sort of generic matrix. So what's y22? Y22 we would go to the second row and second column, so that's 2.2. Y41, we'd go to the fourth row and the first column, so that's going to be 3. And then y14, we'd go to the first row and the fourth column. There is no fourth column, so there is no y14.